Yes.
Okay, so we introduced last time the Kramer's rule, which can be used to solve a linear system of equation. Okay, I will summarize it here. So just when you have a linear system, you can convert it to a matrix form, and then the coefficients of x1 will constitute the first column of your matrix. The coefficients of x2 will constitute the second column, and the coefficients of x3 will constitute the third column. And then, in order to find respectively x1, x2, x3, you take this matrix. First, you replace, to find x1, you replace the first column by the column of results, b1, b2, b3. And then you say that x1 is the determinant of this matrix over the determinant of the matrix of coefficients as it is. Okay, so you don't do here any modification. Just for this matrix, you place the result vector in place of A1, the first column, which are the coefficient multiplying x1. The same to get now x2, same procedure. Now you put b1, b2, b3 at the place of the coefficients multiplying x2, and you divide by the determinant of matrix A. So here, this is the same matrix as you can see, just I am modifying the upper matrix. So here for x3, I just put b1, b2, b3 in place of the coefficients multiplying x3. So it is an easy technique, but as the number of equations will increase, I will need to take a lot of time of computation to be able to calculate the solution. This is why we say that when the number of equations is higher than 3, this method is not efficient because it will need a lot of time. Okay, so here we have an example of a solution of a 3 by 3 system. So as we said, the first step, we can transform from the linear system into a matrix form. So it's very simple here. I just treat the coefficients of x1, 3 to 2, the coefficients of x2, minus 2, 2, 0, the coefficients of x3, plus 2, plus 3, minus 3. I will constitute my matrix A times x vector, which is x1, x2, x3, equals to the result vector is 1 minus 2, 0. And now to find x1, I get the determinant of this matrix where I replace this term by minus 1 minus 2, 0. And I divide by the determinant of matrix A. Then I should calculate the determinant as we have seen yesterday. It's very simple. I just put, for example, for this matrix here, I put plus, minus, plus. So I will start by plus 1 times, if I drop the column and row here, the remaining terms will be these ones. So it's times 2 times minus 3 minus 0. Okay, and then I do the second term is minus 2 times. I drop now this row and this column. So I get minus 2 times minus 3, which is plus 6. Okay, and minus 0 times 3, so it's minus 0. And the final term is plus 2 times. I just now drop the column and row of 2. I get these 4 elements, and as you can see, it's 0. Okay. Now I will repeat this procedure of calculation of determinant for all of these. And once you calculate the determinant of A, you will use it here and you will use it here. So you still have to compute the determinant of this matrix and the determinant of this matrix, and you can get the values of x1, x2, and x. Now, it is clear that in the Kramer rule, we might have a problem of time in case we have a matrix larger than 4, and plus in case we have a determinant that is 0, because when the determinant is 0, we cannot solve using this method since we are dividing by 0. Okay, and in general, when the determinant is 0, we are in we have two possible scenarios: infinite solutions or no solution. Because if you go back to the main possibilities we have seen together, here, for example, when you don't have solution, if you calculate the determinant here, what is matrix A? Matrix A will be 3, 3, and minus 1, minus 1. This is matrix A. Okay, so if you calculate the determinant of matrix A, you do 3 minus 1 minus 3 times minus 1, we will get a determinant of 0. So when you have a determinant of 0, you might have this one possibility is to not have any solution. Okay, and the second possibility is to have infinite solution, because here also you will get the same A. So here, if you same determinant, it's 0, because if you put your matrix A, it's 330, and it is minus 1 minus 10. So now if you do 3 times minus 10 minus 30 times minus 1, also here the determinant will be 0. So a determinant of 0 in general is when we have infinite solution or no solution. Okay, so of course using the Kramer rule with a determinant of 0 will not work, because you cannot divide by 0. Now the second problem is the time. So if we have if we have a 4x4 system, look the amount of computation, the huge computation we should do. So it's not efficient to use this rule. This is why we will develop together new techniques, okay, in order to be able to solve a linear system of equations. Okay, so even in the Kramer method, not only if determinant is 0, it's a problem. Also, if the determinant is too small, we might have a problem, because you know that in case the determinant is too small, then we might have round off error, because we are dividing by a very small number, and we will not be able to trap with the calculator maybe all digits, so the round of error will increase in this case. Okay, any question on this part? Okay, another type of systems we have seen together is the ill-conditioned system, and I told you that we will see this in example. So what is mainly the characteristic of this system? This system will give us a solution, but we cannot trust it for a certain, so if the degree of uncertainty is very high. Because here, for example, if you take this system, 2x1 minus x2 equals to 3.01, and 2.01x1 minus x2 equals to 3. You can solve it, okay? You can solve it. You will get one possible solution, which is x1 equal minus 1 and x2 equals 5.01, okay? But here, you will see if you calculate the determinant of this matrix, you will see that it is close to 0. This is why when the determinant is close to 0, your solution, the degree of uncertainty of your solution will be high if you just vary one of the numbers in this equation by a small amount. Because here, if you calculate the determinant of this matrix, you will get the following. You have 2 times minus 1, okay, minus 2.01 times minus 1. So you will get a value very close. The value is very close to 0. So expect when your determinant is very close to 0, you can say that you have an ill-conditioned system. Because if you vary now, if you try to vary little bit one of your numbers, so here, if you just vary by 1%, B1, and you solve your system, okay, then you will get now a very different, look at the difference in the solution. By just changing 1% B1, the value of x1 and x2 have changed dramatically. So here it's times 4, and here it's nearly times 2, times minus 2 nearly. So this matrix is so ill-conditioned that a 1% uncertainty in the right-hand side vector will give completely a different answer. So I cannot trust my solution within a 1% uncertainty. So if I just don't have these exact values, I will get a solution that is very different. Okay, this is what we call a nil condition system. And what is the cause of this? The cause of this is that my determinant is very close to zero. So I am just at the extremity of the case of having no solution or having infinite of solution. This is why by changing little bit one of these numbers, okay, if you change the right hand side by a small amount, your solution will vary a lot. Now, as we talked about, Kramer's rule present one main disadvantage is that for high number of equations, it will take a lot of time, and efficiency of calculation with a small time is very important, especially when we deal with several operations. You know, computers will do a very large number of operations. So one of the main issues when we deal with programming or when we use computers is to reduce the computational time. This is why we should develop new numerical techniques that can solve for a linear system of equation with a much lower number of operations. This is why we will first introduce one method which is called naive Gauss elimination, okay, which is an efficient method for solving large system of equations, and it consists mainly of two steps. The two steps are first forward elimination, which is in this step we want to reach an upper triangular matrix, and you will understand now what do you mean by this. And the second step will be to do back substitution to solve for the numbers. So at the end of the explanation, you will be able to understand what are these two steps. So to start with, what is forward elimination and why we need to do it? To understand this, we will just take a small example. So consider the following matrix, okay, is the following linear system of equation, and we want to convert it to matrix form. So as we said, we can write it in the form matrix A times matrix X equals to matrix B. And matrix A will be constituted by the coefficients multiplying x1, x2, and x3. And as we said, the first column here will represent the coefficients of x1. The second column will represent the coefficients of x2. And the third column will represent the coefficients of x. Okay? Now, it seems that it's a little bit complex. So here, because I have a lot of coefficients, I don't have zeros. When I have zeros, it will help me. And I can put zeros in a way to give me a very fast solution. For example, let us see how. If I tell you, I can replace this system of linear equation by another system, but that will give me the same solution, of course, because if it will not give me same x1, x2, x3, it's meaningless to do that. So I want to try to find another system that is equivalent to this one, so that will give me the same solution for x1, x2, x3, but in a way to have my coefficients different. How? So if I can create a matrix here in a way to have zeros at the lower level, okay, this is called an upper triangular matrix, because if I take the diagonal, below the diagonal I have 0 elements. What is the importance of this matrix? Take a look now at this system. You can now, if you just take a look, you can tell me what is x3. Can you tell me what is the value of x3 here? Look, this if you have this configuration, this will be equivalent to this system. Okay, look, because for example here, this third line, when you multiply the third line by the column, what do you get? You get the following: 0x1 plus 0x2 plus c33 times x3 equals to d3. So this equation is very straightforward. I just can deduce from it that x3 is equal to D3 over C33. So when you have zeros, this is the advantage of having an upper triangular matrix. In this way, you can solve. This is why we call it backward substitution, because when we ensure zeros here, you can start to solve x3, then substitute back to get x2, then substitute back to get x1. Okay, just let me check. Yes, Michelle, exactly. It's D3 over C3C. Okay, so here, what we can deduce is that if we are able to transform this system to a system of this form, having the same solution, then we will be able to compute in a much faster way what will be x1, x2, x. Okay, so now what will be the second equation, the equivalent second equation? If you do it, it's 0x1 plus C22x2 plus C23x3 equals to D2. So now, since you have already calculated x3 from this step, by substitution, when you substitute x3, this is called the backward substitution, because I found x3 first, the last term, I replaced in second equation, now I get x2, and once I get x2, I know the values of x2 and x3, so by substitution I get x1. So I will work in a backward way. This is called backward substitution. Okay, and the step, so this is the backward substitution, and the step to go from this form to this one, you need to go from a full matrix here to an upper triangular matrix. This is the forward elimination. Okay, and we will see together how to perform this, how to perform the forward elimination. Okay, any question on this part, on this slide? Okay, so now my next step is to see how can I go from a full matrix to an upper triangular matrix while ensuring that the two systems are equivalent. What I mean by this, they will give me the same solution x1, x2, x. Okay, so this is what I want to do. Okay, I will give you an example, because when you see the example, you will understand the general math. Okay, look, if you have a system of equations, if you play with equations, and let's say if you add these two equations, then you can say that you obtain another equation that is that will be if you want appropriate for your system. And if I add these two equations and I get a new equation, I can use it to replace one of the two, because this equation is I got it from proportionality between these two equations. And sometimes, okay, you can do any operation. If you can just subtract two equations, add two equations, you get a third one. Okay, it will be equivalent, and you can replace one of the two equations by this equation. So, for example, here, if I just add these two equations, try to do it. If you add these two, you will get 2x1 minus 2x1, it's 0, x1, minus 5x2 plus 10x2 is 5x2, plus x3 plus 2x3 is 3x3, equals to 3. If you try now to replace all this equation by this one that was a combination of the two equations, if you try to solve the system on your calculator, you will get the same solution of this form. You can also now replace this second equation by this one, because you got this equation by combining these two. Okay, so this equation can replace now or the first or the second equation. So this is the idea that we will use for forward elimination. We will combine equations in a way of that it will create coefficients of zeros where desired. So here I desire to transform this matrix to another one which will have all elements below the diagonal 0. So I want to transform -2 to 0. I want to transform 3 to 0. And I want to transform 2 to 0 while keeping the same solution for the system. How can I do this? I can do this by combining the equations and replacing and getting a new equation that can replace, for example, first I will replace this equation in a way to have 0 here. Then I will replace this equation to have 0. And then I will do a third operation to get 0 here. Okay? What will be the idea?
سوري بس انا ما فهمت، ما اذا جمعنا الواحد الاولي والثاني بيبقى لنا x1 بصير عندنا 3 انكونيو مع 2 ايكواسيون.
لا، ما انت عندك بدك تزيد على هول 2 ايكواسيون الثالثه ما بتروح لمطرح، بتضل مثل ما هي. اوكي؟ يعني انت if you did the addition of these two طلع لك equation 3. السيستم الجديد حسميها equation 4. اوكي؟ هول equation 1 2 3. اوكي؟ if you added equations 1 and 2 طلع لك new equations اللي هي equation number 4. What can be your new system of 3 equations? You can take it as 1 3 4. هيدا system جديد. one possibility. ثاني possibility your new system can be 2 3 4. يعني حيضلوا 3 equation بس equation 4 can replace أو equation 1 أو equation 2.
اوكي، لان انا فكرت انه بيطلع لنا 2 ايكواسيون، طلع
لا.
بس وحده نتركها ونزيد عليها وحده ثانيه.
لا اكيد لا، هيدي الوحده بدك تزيد عليها او 1 او 2. اوكي، وحده من الاثنين you can keep. اوكي شربل. طيب شربل انت did you submit the homework? Why you didn't؟ عم شوف you didn't submit it. Did you send it by email شي؟ طيب okay, we can talk after about this. Yeah, let us continue. Okay, so now what is the general technique we do to get an equation for which the coefficients are 0? It's very simple. And I want, after doing this operation, okay, I want to get 0 here. Okay, so what should be the coefficient that I should multiply by the first equation in a way that if I subtract the two equations I will get 0 here. هيدا الcoefficient اسمه, this one is A21. So the first subscript stands for the number of equation. The second subscript stands for the subscript of x that I am multiplying by. يعني أنا I'm multiplying the coefficient by x1. So this subscript is 1. And since I am in line 2, this subscript is 2. So this is A21. Okay. And this subscript here is A11. Okay. What I will do here, I will multiply, okay, the first equation. If I multiply the first equation by A21 over A11, what will happen? هيصير الcoefficient of x1 بهالاequation. When I do the multiplication, I will get that the coefficient of x1 will become A21. ساعتها if I do the subtraction, if I subtract equation 1, the resulting equation 1 from equation 2, بيطلع لي coefficient of x1 0. This is the idea. This is why I say to be able to get this coefficient 0, I will do the following. I will multiply the first equation by the factor f21. Why I'm doing this? I'm doing this to transform this term, this coefficient, to a coefficient equal to A21. This can be done by multiplying equation 1 by this factor, A21 over A11. And then the next step, I subtract equation 1 from equation 2. بس أعمل minus. When I do this operation, هيصير coefficient of x1 0. Let us verify this here in this example. So the technique is to take equation 2 as it is, اللي هي minus 2x1 plus 10x2 plus 2x3, and I subtract from it, okay, equation 1 multiplied by the factor, this is f21 here. In this example, f21 is a21 in this example is -2 over a11 is 2. So I should do -2 over 2 times equation 1. And then what do I get? This equation will remain as it is. When I multiply this equation by here لأنه it's minus يعني plus 1 هون ما فرق شيء لأنه الفاكتور كان equal to -1 وأنا عندي minus so صارت +1 يعني it is equivalent to add equation 1 to equation 2. If I do now the addition, okay, I can verify إنه حيطلع لي coefficient of x1 0 and this is what I want. So the new equation will be 5x2 plus 3x3 equals to 3. So now my new system, okay, حيكون equation 1 بتركها as it is and I replace equation 2 by this one. Okay. Saeed, here it's right. In this problem معك حق, you can just add them. But if I change the coefficient, إذا بعطيك example ثاني, here -3. If you add them, you will not get 0. And I'm giving you a general method that will work for any matrix. هون ثابت إنه if you add the two equations, you get 0. Okay, but it will not be the case for any other matrix. هيدا rule will always work. لأنه شو ما كانوا ال coefficients, if you multiply equation 1 by factor f21 اللي هو a21 over a11, then you subtract it from equation 2, you will get coefficient of x1 in this equation equal to 0. Okay? Okay. So now I will update my matrix. My new matrix after this first step will be as follows. حتضل هيدي بيسموها ال pivot equation. Okay. So why we call it like this? Because we combined equation 2 with it to get a new equation. So this pivot equation will remain as it is. It will not be affected. Now equation 2 will be replaced by another equation that will, in a way that the system will give me the same solution. So until now I was able to set this number as 0. And we call هيدي بسميها in this step, this is the pivot equation. Because I used a combination of equation 2 with this one to be able to change the coefficient to 0. And in the first step, تقدر أوصل هون لزيرو هيدا اشتغلنا على هيدا coefficient because we did a21 over a11. So my pivot, this was called pivot element. So this was my pivot element in the first forward elimination step. ليش بيسموها forward elimination؟ لأنه أنا ببلش أحط 0 هون. يعني ببلش بأول coefficient I put it as 0. هلا أنا هول الdiagonal ما رح غيرهم. Everything above diagonal will remain as it is. The second element that I want to transform to 0 is this one. And now my next step, this is why we called it forward elimination. أنا ببلش to put this as 0. I move now to this second element to put it 0. And in the third step, I want to put instead of this element 0. Okay? So it's forward لأنه we start from 1 to 3. بينما ال backward substitution, we solve for x3, then we solve for x2, then we solve for x4. Okay? So now, in my second step, حتضل ال pivot equation 1. بس ال pivot وحيضل ال pivot element هو 2. لأنه now what I will do in this step now, I will follow the same technique I did. But now, instead of combining equation 2 and 1, the equation 2 I already combined it to 1. خلص طلع لي 0 that I desire. I am done with it. Now I will move to combining 3 and 1. Okay? So now in this step, this is still my pivot equation. And my pivot element is 2. Because now I will multiply the first equation by which term? Now I will multiply the first equation by a 3 1 اللي هو 3
3 over 2
over A11 يلي هو 2. يعني هيدا هو my pivot element because I'm dividing by it. Okay, and then I will multiply the equation. Okay, I will multiply the first equation by 3 over 2. So now let us do it. The third equation is 3x1 plus 2x2 minus 4x3 equals to 2. I will subtract from it f31 times the first equation. f31 هو a31 3 over a11 اللي هو 2. So this is minus 1.5 times equation 1. Now if I perform the operation, okay, I will get the following. هيطلع لي أول equation هي 3x1 plus 2x2 minus 4x3 equals to 2. I want to subtract from it the following equation. When you do 3 over 2 times 2x1 مثل ما بتلاحظوا ما نحن the purpose, this is why we multiply by a31 over a11 لأنه a11 over a11 بتروح ما بيبقى إلا a31, so it's minus 3x1 حدغري فوت الماينس على الايكويشن. اوكي so it's minus 3x1. عندنا هون 3 over 2 times 5 times minus 5 already في minus يعني plus 15 over 2 which is 7.5, so plus 7.5 x2. And now I have the third term هو 1.5 x3 وعندي minus يعني minus 1.5 x3 equals to this factor هون هو 3. If you multiply it by minus 1.5 it's minus 4.5, so you get minus 4.5. and now I add the two expressions and أنا الماينس فوتته على equation. okay, so now if you add the two expressions 3 minus 3 it will cancel out. You have 2 plus 7.5, so it's 9.5 x2. You have minus 4 minus 1.5 يعني minus 5.5 x3 equals to 2 minus 4.5 which is minus 2.5. okay, so we can deduce then no, the third equation is this one. okay, so now I can replace the third equation by this equation اللي حيكون عندها coefficient of x1 0 as desired. okay, so now my system is as follows. I still need just to replace this element by 0. so لحديت هلا I combine 2 and 1 to get here 0. I combine the 3 and 1 to get here 0. خلاص, I cannot anymore use this equation because I already combined this equation with the two other equations will eat one equivalent equation. So now, because you use this equation with 2 and 3, you can not use it anymore. Okay, so now this equation will not be my pivot equation anymore. Now I want to choose another pivot equation. I will move to the second line. So now my pivot equation will become this equation in this step because already I used equation 1 with 2 and 3. But then the one possibility is to use 2 with 3. Okay, so now what I want to do, I want to transform this element to 0. To transform this element to 0 بما انه هو second element بالايكويشن يعني البيفت element تبعي حيصير the second term بالايكويشن number 2 اللي هو 5. okay, so now this is in this step this is my pivot equation